Hi, everybody, and welcome to the SIG KCP Edge community meeting for December 1st, 2022. I'd like to remind everybody on the call that we have a contributor code of conduct as contributors and maintainers in the CNCF community, and in the interest of fostering an open and welcoming community. We pledge to respect all people who contribute through reporting issues, posting feature requests, updating documentation, submitting pull requests or patches, and other activities, and basically just be nice to each other. Thanks. Okay, so today we have queued up two items, one on edge placement from Jun Duan, and Yuji Watanabe would like to talk to us a little bit about policy management. So without further ado, we'll get started. Yuji, you were in first in the queue, so if you'd like to take center stage, share what you would like to.
Let me share my screen. Can you see my screen?
Yes.
Okay, thank you. I'm Yuji Watanabe, so I'm from IBM Research. Today, I'd like to present our very early stage idea of the policy control for KCP8. So this is my joint work with my colleague, Yanagawa Takumi, and also the Yorktown folks, Paolo, Hamid, Ting, and Konstantin. And before going to the details let me explain about this talk. So this is still very early stage idea. So we are very new to the KCP at Edge. So please give us any comment, feedback, and all the material, this slide and design document and demo recording and some prototype implementation, all links are available here. So please please interrupt me even if during this presentation, or maybe you can give the comment to the design doc directly. Okay, so first let me explain about what is the policy control. I'm trying to explain this in this page, in this slide, in this talk. And basically the verify resource by policy. It's like the admission control, or sometimes maybe the background scan for the resource. So typical the implementation is a Kiberno. Actually, we are doing some prototyping by using this Kiberno. Kiberno is a Kubernetes native policy engine. The policy and report are described as a Kubernetes resource, and it verified by mutate generate resource according to the policy. So other example is OPA gatekeeper or Kube1M, but we are trying to address generic policy control, but prototype we are doing the prototype based using the Kiberno. Okay. So when we try to do the similar things policy control for the KCP scenario, this is a very high level idea what we should do. So we have the KCP side and cluster side, and if the resource comes into the workspace, it syncs to the cluster. So the resource check should be done at the workspace level and also the cluster side. So the reason we need to do the policy control also in the cluster side is the cluster edge scenario. This cluster may be disconnected. So if during the disconnected phase, cluster may be accessed directly. So this control also required. So basically the requirement like we put the policy control here, and if user defined policy control is become effective according to the policy, and the policy can be also enabled on the cluster side, and all the report is report is generated here, so it's also available to the user. So this is a very high level idea of the what we are trying to achieve by this policy control. Okay. So and so for enabling this, we have some the proposed design. So basically we are using some the cluster for the policy control. This is connected to the workspace, managed workspace, maybe say the policy control. The same, if user defines some policy control, then policy control operator we proposing is automate the enabling the backend web API, then enable it as the admission webhook here. So resource in the workspace is automatically checked before admission, or after admission, it's scanned by this backend by the background scan. So this mechanism for enabling this admission webhook backend must be effective, so that this policy control operator automates the enablement of this backend key value. So this is the workspace side protection. The cluster side protection is also the key value. So the goal is to enable the key value run on the cluster side. So for that, the policy control operator creates the resource, then automatically synced to the cluster side, then Kibernel is automatically installed. So after starting the Kibernel, the policy is synced to here. So then the policy control works. So Kibernel automatically generates the report by the background scan. So report is created in the workspace here, but the cluster side protection generates the report here. So we need to have the mechanism to deliver this report to the workspace side. So this is a up sync, so backward syncs. So for this, we need to use some up sync mechanism. Maybe it's in the it will be enabled in the design, but by using that, we can send back the report to the workspace. Then policy control automatically summarize the report to and report back to the original policy control user. So this is proposed. So okay, so this is high-level design. So we did some prototype implementation of this by using the Kibernel and one KCP, one sync target cluster, and one policy control cluster. So by using this policy control operator, the admission webhook on the KCP side automatically enabled, so that if you create some config map on some workspace, it's blocked by the workspace side admission control. Or if this is synced to the cluster side, then some file violation found, it's reported at the cluster side, and it's sent back to the sync target status. But this is not, we are just did some short, small code changes on the sync target status code. But maybe this part is just our experiment. So we should use the more official way to for the upsync. So maybe some comment here. Yeah, upsync is now available, so we should use the upsync. So
it's not immediately available, but at least there is a pull request.
okay, thank you so
Ongoing
much.
work.
Yeah. Okay, thank you so much. And for during this the prototyping, that we have several issues, challenge things need to be resolved. So the policy report aggregation for the policy control, policy report aggregation, how to conflict the cluster scope policies at the cluster side, and how we can to make the Kiberno to the workspace aware. So now that we are handling the work, we are standing up the Kiberno per workspace, but we may need some change in the Kiberno size for dealing with the workspace. And for Thinker side, currently we are syncing the namespace scope policy, but for cluster scope policy, that we need some sync mechanism. And admission errors must be handled in the Thinker, and some multiple cluster from the one workspace or one resource to the multiple P cluster or upsync. So there is some items we need to find the good way for the in the sync mechanism. But anyway, so this is a high level idea. So please give us any comment and question regarding to this proposal or the approach to the policy control problem. So okay, so thank you.
Maybe I just have a question about the problems or the challenges on the Thinker side, the previous slide. Yeah, normally, I mean, the thinking of cluster scoped resources is in fact wired inside the Thinker already, but quite limited because obviously it's something that we cannot, for which we cannot open the door. Putting cluster-wide resources inside a physical cluster is very impactful. So for now, it's mainly on really named and hard-coded list of resources. For example, PVs, that storage was the main and first driver for this. But obviously we could, discuss on having some sort of gating mechanism, very, controlled, that would enable you, allowing other type of resources that you would control to be.
For example, in my proposal for edge placement, an edge placement object type or resource, there is a field that holds a list of GVRs or GVKs, I forget which, of cluster scoped resources to sync.
Yeah.
Yeah, I mean, probably we have to start, possibly open an issue, I don't know, to start discussing about, the needs and the limitations and the security gates we want to provide here, and to avoid, having side effects on physical clusters.
Yeah. Thank you.
I'll also note that this connects to the difference between the TMC model and the edge model, where in the edge model we want these clusters to operate independently and while disconnected. And in that kind of model, you tend to want more of the cluster scope resources to go there. You want the source workspace to look like a model of what the edge cluster looks like. So there's less service provider, stuff lying around because there's not so much service providers.
Yeah, that's much more declarative objects that may be cluster wide that you want to send to the edge, right? Is it what you mean?
Yes.
Sure.
Yes. Thank you so much for your comments. Do
So
you
I
have
also have some
any?
questions here.
Yeah.
What is this about? This item here about conflict in multiple cluster scope policies?
Okay, so thank you for your comments. For example, if the policy is synced to here, so maybe I'm assuming so if the policy cluster scope policy comes into here, so cluster scope policy for the Kubernetes case, it affects all the other namespace. So if you, for example, if you have the multiple namespace to the sync to this KCP side in one cluster, one cluster scope comes into the one namespace. So that cluster scope namespace affects to the another namespace, which is synced to other workspace. Maybe that is a kind of the conflict. So if so that is the one things we need to think about. So from the policy side perspective.
I'm not sure I followed it. So certainly policies are additive, and this problem is not unique to Edge. So I'm a little
Yeah.
confused about.
Yeah, this is not this is very generic problem for the cluster scope. So if the cluster scope deployed to the cluster, it affects all the namespace. So yeah.
And this would be a problem even if there were no Edge. This is just a Kyverno issue.
And not Kubernetes, yeah.
Why is it not?
Yes, sorry.
Why is it
You
not?
had your hand up. You want to jump in there for just a second?
Hello, can you hear me? Hello?
Yes.
Yeah. So for the thought is if the cluster scope resource is deployed here, so it affects the other. So the cluster scope policy. So one use case is user wants to deploy the cluster scope policy in the sub namespace by this syncing mechanism, but cluster scope policy should
Wait, slow down. I'm not sure I'm following you. I think I just heard you say if the user wants to deploy a cluster scope policy in a namespace.
Yeah, Kibeno is running on the some namespace. So that
Oh.
the user wants to apply the control by policy to the entire cluster. That is the use of my.
Okay, so the user does not want the cluster scope policy to apply only in a namespace. He wants it to apply in the whole cluster.
Yeah, user wants to apply the policy to the whole cluster.
Right, and that's something that can be done in Kyverno without Edge also, right?
Yeah.
Okay, go on.
So that is not the issue for in the Kubernetes, but in the KCP workspace and namespace sync mechanism. So my original assumption was namespace, or each namespace should be isolated. So that my original so that I thought that was the reason of why namespace scope resource only can be synced to the target cluster. But maybe I'm wrong. Yeah, I'm just that was my original thought. But maybe it's not the right correct assumption.
Yeah, I think the type of, if I can answer maybe, the type of conflicts you're mentioning, we also very basically face that in the currently, simple cluster-wide syncing that we implemented. Yeah. If you think of PVs, for example, and there is PVs are really cluster-wide, and we don't, when we sync cluster-wide resources, we sync them as cluster-wide objects on the physical cluster, obviously. And so simply if you find an object that already exists with the same name, but a different origin that doesn't come from the same KCP workspace for the same sync target, then just an error is produced. So for now, it's mainly the user, on the KCP side, the user responsibility to schedule for syncing objects that will not have the same name as as the name of an already existing cluster-wide object in the physical cluster.
Yeah.
That's for now very simply managed, but at least it's tested and the error is reported.
Maybe it's kind of the user's responsibility to manage the policy cluster-wide policy to the apply to the cluster. So that is not the issue. When we tag the user is a single tenant, so not the multi-tenant case. The single tenant case, it's not.
Okay, I'm going to call on myself.
Yeah.
So Yuji, Yuji, 2 questions for you, more community-based outreach. Have you spoken to Joshua Packer, who I see is actually on the call, about what he's working on with ACM policy with KCP? And and have you already looked at what Kyverno and OCM or Kyverno and ACM are doing today? Are you familiar with that integration?
Yeah, I'm familiar with ACM, but and Kyberno, but I need to talk with Josh on how the KCP Kyberno ACM. So that I need to talk with Josh on that. That is your question?
Yeah, that was my question. I just wanted to make sure.
Yeah.
Yeah.
I know the Kyberno itself and the ACM side, but I don't know much about the Kyberno and the KCP integration on the ACM. So yeah, that is the current state.
Okay.
I will check if Joshua Packer, correct?
Yeah, he's on the call
Yeah.
here.
Okay.
Thank you.
I will. Yeah. Thank you so much.
All right. Any other questions for Yuji?
Yeah, could you put up your slide of issues again, or open issues?
Sorry, could you say again?
Can we see page 7 again?
Okay. Yeah.
So what is the issue here about trigger actions and notifications from policy violation?
Yeah, this is a very generic term. Sorry, if we find the policy, we have the policy control operator, so we can detect the policy violation by checking the report. So after from that, we maybe some action, maybe remediation or something, or notification should be triggered. So that's a very generic statement. So
Are you saying this is a Kyverno issue?
no, it's a policy control. Maybe this is one of the function we can address in the policy control operator. Not Kyberno. Kyberno can detect the policy violation and create report. So we can use that report to trigger some action.
I see. So the point is making connections out from
Yeah.
Kyverno to
Yeah.
have some effect.
Yeah.
Okay, thank you.
Yeah.
Okay.
All right, I'm gonna call on myself again. Also, Yuji, are you familiar with the policy results working group?
Sorry, policy.
Policy results?
No.
There's a Kubernetes working group out there, and I had the link, and I don't have it right now, but it's one of its main objectives is to be able to surface the results of policy scanning for any number of security related projects that are out there. And you have this upsync from pcluster to workspace. So when the Kyverno generates a report, it has to push that report up to be used somewhere, right? What's nice about policy results is it's already hooked into Security Compliance Center from IBM. It already works with OSCAL. So you might want to look at policy results.
Okay, yeah. We will check that.
Great.
Thank you so much.
Thank you.
Another question here in the syncer section, what do you mean by sync one resource to all P clusters?
Yeah, this is we have I have very limited idea, but maybe it's very related to the discussion the last week. The Paolo did for the multi schedulers. So, but what it means, one I put the one resource to the workspace, then one space resource maybe the policy resource. Maybe it's deployed to the multiple P clusters bound to the that workspace. One workspace to multiple P clusters. So policy should be deployed to all the P cluster. So for control, policy control. That is the purpose of this.
Right. So you're aware that for edge multi-cluster, we have defined the concept of a placement that does not mean select one location. It means select all the locations.
Yeah. We just start the learning about that. So maybe this is this part is a question. So this is if this is already resolved, I'd like to know. So or if this is already addressed, we will check. We will follow the.
Okay, there is a
But-
difference between location and cluster, so there is still something of an issue there. But okay, I understand what you're saying. Thank you.
Basically, this is people class. My this meaning is a location or some sync targets.
Yes, thank you.
Does anybody have any more questions for Yuji?
I have just a question about what is the difference maybe in those questions in the same page between multi-clusters in a workspace and sync one resource to all P clusters. I mean, I'm not sure I understand the difference. I mean, the problems or the question it relates to.
So this
Multi-clusters in a workspace.
For example, in the workspace, this, for example, this namespace should go to the this cluster, and this namespace should go to the this cluster. So I'm trying to understand the.
Oh, you mean that
yeah.
several namespaces in a KCP workspace
Yeah.
would be synced to distinct locations?
Yeah, something like
That's
that. Yeah.
currently, at least with the TMC placements, that
Mhm.
probably would be also generated by your edge placements. It's already possible. You have a namespace selector on the placement, and then the location that is assigned to a namespace depends from this selector, in fact.
Okay. Yeah.
Yeah, June is up next, also giving a discussion about edge placement. So you might benefit from that discussion.
Yeah. Thank you so much.
Okay, thank you, Yuji.
Thank you so much for your all comment and question. This was really helpful. Yes, thank you so much.
Okay, next up, June, would you like to show us a bit about edge placement and really timely based on the comments and questions for Yuji?
Sure. Let me share my screen. So I had some initial trial to try to implement the scheduling controllers. And after this trial, I also have some questions to trying to seek the comments and helps from the community. So let me go to that issue. So my initial trial is trying to implement Paolo's proposal on the design of the HMC schedulers. Paolo proposed several options. I'm starting with the most basic one, the option 1, which is actually a simplified version of this option 2. I'm starting with this KCP dev / controller runtime example, because looks like it is made by KubeStellar, and it is very good for quick hands-on. And in this initial trial, I introduced Edge Placement API that is partially based on Mike's proposal. And also I write a controller to reconcile Edge Placement API objects. I was able to realize a multicast pattern for workloads, meaning that I can distribute a deployment in the user's workspace, which is here in the user's workspace, the workload management workspace, to multiple mailbox workspaces. I actually have a recording for that. I can show that later. And also during my trial, I hit some issues. The major issue I hit is about watching, especially watching multiple KVRs or watching KCP APIs. I will be talking about the details later. Maybe I can show the recording before I delve into the details. I have this recording in a separate window. You can see that I have 4 terminals here. Let me play the recording. I have 4 terminals here. On the left, in the bottom, I have the KCP server running. And then on the left, in the top window, I'm going to use KubeStellar to talk to the KCP server. Then I have a third window, which is on the right-hand side in the bottom. The third window shows the implementation of my Edge scheduler. And finally, I have the fourth window, which shows the peak cluster I'm going to use in this demo. For the peak cluster, I have a few more words to say. If we get namespace here, let me pause the recording. You can see it has 6 namespaces for the sinkers. I'm kind of overloading this single peak cluster by hosting all the sinkers in this one single peak cluster. This is just for simplicity. So this may cause some confusion, so I'm trying to explain this here beforehand. Let me go ahead, continue. So let me show the exact API object of the edge placement I'm going to use in this demo. So in this edge placement object, it has a list of location workspaces. In this list, we have 2. And also in the spec, we also have a location selector, which specifies in each of the location workspaces, I want to select locations match this label, which is environment must be production. Before I create that edge placement, I want to check what's inside the location workspaces. I have a tiny script to show that. In the first location workspace, I have 3 locations, 3 sync targets. There is a 1-to-1 mapping between them. And also in the second location workspace, I have similar thing, 3 locations, 3 sync targets. That's why I have 6 sinkers on the right-hand side in P cluster. And finally, in the users workspace, I have a workload, which is a deployment of Nginx named Nginx EP, where EP stands for edge placement. And then let me check, make sure the sinkers are running correctly in the P cluster. You can see there are 6 sinker pods. I also want to, yes, the 6 sinker pods corresponds to the 6 sync targets. I also want to make sure that the P cluster is clean, meaning that no workloads is currently scheduled there. Now, let me create the edge placement API object we just showed 1 minute ago. So using this command, I created the edge placement. After that, let me check what's inside the location workspace again. So we can see we have two freshly created TMC placement. And those TMC placements corresponds to the two locations who match the label environment should be protection in the spec of the edge placement. In addition to that, we can see that the workload, which is Nginx EP, is copied from my user workspace to this location workspace. Things are very similar in another location workspace. I have freshly created TMC placements corresponding to the two matching locations, as well as the copied workload from the user workspace. In the user workspace, we have this freshly created placement, which have a different API group with the TMC placement. And finally, let me check what's running inside my P cluster. I'm using the same command again, but this time we can see there are 4 pods of Nginx being running there. Why do I have 4? Because I have 2 from the first location workspace corresponding to the 2 selected locations, and another 2 from the second location workspace. So this summarizes the demo, which I showed how to dispatch the workload from one single workspace to multiple workspaces by selecting multiple locations using one single edge placement object. So this is what I have for the demo. And next I want to talk about the issues I hit when I was doing the implementations. First issue, before that, let me, I took a look at the KCP code. I found that it is really straightforward for the TMC controllers to set up watches using the Kube shared informal factory and KCP shared informal factory. So just use the 3 lines of code. It set up watches for the namespaces, locations, and placements. And when I was trying to do similar thing in my implementation, I found that cases are slightly different, because in this controller runtime example, which is what I'm following, I found that the controller is watching the virtual workspace corresponding to the API export. So it looks like this. If I just doing a query against the virtual workspace, which is from the my export API export, I can get all the edge placement object across all the workspaces. But using this pattern, I didn't find a clearly easy way to set up multiple watches like this. That's just a one-liner to set up a watch. I didn't find an easy way to do that. That's the first issue I have. The second issue I have is how to watch KCP APIs, because in my demo, I'm watching my custom API, which is edge placement. When I try to set up watches for KCP APIs, for example, locations and placement, I try to follow the same pattern, which is to watch the corresponding API export. I found that for example, the placement and locations are from this API export in a root workspace, but it is not working as this my export API export. So maybe this is by design, but nonetheless, I didn't find a easy way to watch KCP APIs in this controller runtime example. So after my trial, I have a feeling that have a feeling that this controller runtime example is more for the users who's going to be using the asset offered by KCP, and not that it's suitable for contributors to KCP. And I have a feeling that I have to switch to lower level libraries, such as client Go, which is customized in KCP-DB, and also some other components in this package. But since I'm still ramping up, I'm not familiar with the entire big picture. So I want to discuss with the community, with the experts. Sorry.
June, we got a hand up from Andy.
Oh, okay. Yeah, so I need some, yeah, I'm happy to listen to the pointers or suggestions from the community.
Go ahead, Andy.
The way that you do this is that in your API export, you add permission claims for every single resource that you want to work with. So that would include the, placements and location resources. And so you would only go through the virtual workspace for your API export. You would not switch to the root scheduling API export. And by doing the permission claims, you'll be able to just go to one place and use your virtual workspace's server to do wildcard watches on everything that you need.
So if my understanding is correct, this is basically a permission issue. By correctly config my export, I can also access the KCP APIs.
Yes, any APIs. So the mental model here is that you are a service provider. Your service happens to be edge placement related. And as a service provider, you own certain APIs, like your edge placement resources, and you want to manipulate whether it's read only or read write resources that you don't own and that you're not exporting. Those could be things like config maps and secrets. It can be KCP locations and placements. It could be cert manager certificates, whatever. And as a service provider, you have one and only one URL that you should be using to interact with KCP. It is the URL for your virtual workspace for your API export. And as a service provider, you do not have to ask for permission for your resources in other people's workspaces, because the act of a user creating an API binding is the user declaring, I would like to use your APIs, and you as the service provider have implicit permission to manipulate those resources in my workspace. But if you as a service provider want to manipulate secrets, and you could swap secret for KCP locations and placements, but secrets is a good example. So if you as a service provider are providing edge placements and you want to get access to some of my secrets where I'm a user, you have to ask for permission to access those secrets. And I, as a user, have to grant you those permissions. It's just like in any type of OAuth flow, like in GitHub, for example, where you connect a GitHub application to your account, it will list a screen that says application X would like to have permission for your private repos or your public repos or your user information, and you can grant it or not. And so that's how this permission claim mechanism works. And the idea is that you only have permission to what the user lets you work with.
I see. Yeah, so that's quite clear. I think if my understanding is correct, the permission claims is in the spec of the API export.
Yes.
Yeah, and also there's something which can accept that in the API bindings.
Yes.
Okay, cool. I think I understand what you're talking now. Thank you, Andy. And Andy, I
Actually, I'm
see.
going to call myself. Yeah, I just dropped the link in the chat. There was a good talk that Stefan gave at KubeCon that was recorded and is now posted on YouTube about the API export facility and also, you know, the API and how permission claims work and what Andy just mentioned about, you know, agreeing to allow people to have access to your service, et cetera. So it's if you haven't watched it already, it's a good thing to watch.
Thank you, Andy, for that info. Okay, I think I have got my answers. Back to you, Andy.
Actually, June, I had a further question for you. Did you get your answer when it comes to using the lower level controller?
Yeah, I think this is kind of a more a question with a wider scope, because when in the future when we contribute when we build the Edge MC controllers, I'm not still quite sure about which way should we go. Should we follow the controller runtime example, or should we follow the pattern which is currently existing in KCP, like those scheduling controllers, like this one? I didn't.
I saw
Yeah.
David come in first with a close second from Andy. David?
Yes, sure. I had a question about, in your demo, you mentioned that, you know, when creating the TMC placements based on the edge placement, you also copied the workloads to the location workspace. And
Yes.
I had the question, I mean, did you have anything that...
Well, actually, it was the mailbox workspace rather than location. But the issue is he joined the two. But logically, it goes to the mailbox workspace.
Okay, so yeah, that was my question, because the model now is really to you know, generally distinguish the location workspace and not put any workload in the workspaces that contain the locations and the scene targets. So, but if it's only just for the demo, you know, that's fair.
Yeah, it's only for the demo, and it's a very niche option. It's option 1, and in option 2 and 3, which is proposed by Paula, we have further separations.
Sure. Yeah, understood.
Thank
Thanks.
you, David.
Andy's up next.
If you are using controller runtime, I would encourage you to stick with controller runtime for all client interactions. If you are not using controller runtime, go ahead and use client Go, but there's no need to mix and match unless you really want to, but I wouldn't encourage it.
Okay. Thank you, Andy. Now back to you, Andy.
Yeah, yeah. Was there anything else you needed explanation for? Are you good?
Yeah, I'm good.
Okay, folks. Andy, you still have your hand up, but I assume you've already answered. Okay. All right, team. We have about 10 minutes left. I don't have anything else to really talk about in the queue at the moment. There'll be more follow on now that we had an internal proof of concept that we were working pretty hard at. So you'll start to see some more activity in the community, I think, as a result. Open the floor for any comments or questions at this time. If not, we can close a little bit early. Okay, folks, thanks so much for your participation in today's SIG community call, SIG KCP Edge community call, and look forward to seeing you again. We will have another meeting coming up on, let's see, December 15th. There'll be an agenda posted shortly. I will post a poll, as I've seen other SIGs do, as to whether or not we should have one at the end of December when everybody's out, you know, going to be probably out. So I'll post a poll in the GitHub, and you can take a look at it if you're going to attend or not, and let us know, and we'll talk about it on the next call. We'll talk what the results of that poll yielded. Thank you, sir. Thank you, everybody.